we are going to start with the organic compound, that is the detailed study of the organic compound, that is the sulfuric acid, right. So first of all, you should know that what is actually the formula of sulfuric acid. So it is H2SO4, right. So sulfuric acid is indicated by the molecular formula, that is H2SO4, and when we just talk about its molecular mass, when we just calculate the molecular mass, it comes out to be 98 atomic mass unit, right. So it is the molecular mass of the sulfuric acid. And you know that sulfuric acid is actually called as king of chemicals because it is of great advantage, almost in all the industries it is being used. So it is called as the king of chemicals. So if somebody asks you to just state the king of the chemicals, so it should strike your mind that it is our sulfuric acid, that is H2SO4. Now, what is the structure actually of this H2SO4? So when we just get to see the structure, so it is like this, in which S is bonding the form as I am showing in the figure, right. So this is the structure of the sulfuric acid. So that means in this the sulfur is just forming two coordinate bonds with the O and a single covalent bond with OH and OH. So this is actually the formula for the sulfuric acid. Now see, we are just going to start with its preparation, and before we start with the preparation, you should know that there are many processes by which we can prepare the sulfuric acid, but the most popular process which is being used since 1831, that is the contact process. It was launched in 1831, right. So it is the most popular process for the production of the sulfuric acid. So now we are going to start with the sulfuric the contact process, that how the sulfuric acid is formed. But before we start, I just want that, because there are, as you can see in the figure, there are so many tanks which are actually involved in the the production of the sulfuric acid. So first of all, you should know the general equations which are taking place, so that you can just put those equations, and it will be easy for you to remember that where these chemical reactions are taking place in the different tanks. So just I'm just summing up the equations first, then I'll explain you that what different tanks we are using and what which reaction is taking place in which tank, right. So I'm just going to sum up the reaction first. So it is first reaction which is involved in the production of sulfuric acid is the S plus O2, that is the burning of sulfur. That means sulfur is being burned, and it is burned in presence of the air, in which the air is mostly composed of the oxygen gas. So it forms sulfur dioxide. Then what happens? This sulfur dioxide combines with more oxygen, and it is a reversible reaction, and it takes place in presence of catalyst vanadium pentaoxide, right. So this actually catalyzes the reaction. That means it makes the reaction happen without undergoing any change in itself. So it combines, SO2 combines with O2 in presence of V2O5, giving rise to SO3. Then this sulfur trioxide, which is formed in the second step, we react it with the concentrated sulfuric acid. As you all are familiar that what are concentrated acids? Concentrated acids are something that which contain the higher proportion of the salt content, but the water content is too low, right. So we just reacted with the concentrated sulfuric acid, and you know what we get? We get H2S2O7, which is highly concentrated sulfuric acid called as oleum. Then this oleum is diluted with water, and the water which we will be using will be equal amount, like the water should be equal in amount with the oleum. Like if you have a certain amount of oleum, X, suppose it is X, so that X amount of water has to be added in order to dilute it, and we get the dilute sulfuric acid. So these are actually the reactions which are taking place in this, right. So what do we get to see? First, the burning of sulfur, that is S plus O2 SO2, and you should know that we use only O2, right, because if we, as we know that air also contains the nitrogen. So if we use the air which contains the nitrogen, so it just doesn't make the reaction happen, as it just make itself attached with the impurities. So that is why only oxygen is taken in the air content. That means the oxygen content is taken is too high, and it is free from nitrogen and all. So it just combines and form SO2. And now this SO2 which is formed is not pure, right? It contains certain impurities. Now what are the impurities which are present with this SO2? It is dust particles, it is arsenic oxide. Mainly these impurities are present with this SO2. So that means we need to just purify this SO2, and after purifying this SO2, when it becomes free from this dust and arsenic oxide, it just reacts with the oxygen, that means the more oxygen in presence of vanadium pentaoxide, and it gives rise to SO3. Now the catalyst, like what I am telling you, is V2O5, that is vanadium pentaoxide. Instead of it, we can also use the catalyst palladium, right? But we don't use palladium. Actually, the reason behind is that palladium actually combines with this impurity arsenic oxide. So you can say the catalyst just gets poisoned. So we need a catalyst which do not get poisoned and just increase the rate of reaction. So in order to avoid that condition, we just use vanadium pentaoxide instead of using palladium, right? So instead in presence of vanadium pentaoxide, it gives rise to sulfur trioxide. Then this sulfur trioxide is mixed with concentrated sulfuric acid, and it gives rise to the highly concentrated sulfuric acid, that is H2S2O7, that is oleum. Now the reason is that the question must be striking in your mind, that why I haven't mixed this SO2 with water directly. See, SO2 when combines with water directly, the reaction is highly exothermic and it just gives rise to explosion. So instead of adding SO2 directly into the water, what I am doing, I am just reacting it with the concentrated sulfuric acid, and then we get oleum, and then we mix this oleum with equal amount of water, which give rise to the sulfuric acid. So as you have seen, there are so many reactions which are actually involved in the process. So these reactions are occurring in a specific towers. So this is the figure. See, this is the apparatus which is used for the contact process. So first of all, you should know what are the names of the different tanks which are being used here in the contact process. So this A tank is actually a tank in which the S plus O2 occur. That means in which the sulfur is burnt. That means air is blown into this tank, and what do we get here? We get S plus O2 forms SO2. Right. So here in A chamber, what we get is SO2. There is no such name of the tank, or you can say it is a pyrite burner, that means in which the burning of sulfur is just taking place, right? Now this SO2 produced, as I told you, is not pure. It contains many impurities. The main impurities which are associated with this SO2, I told you, is dust and arsenic oxide. So it has to be purified, right? So this dust and arsenic oxide is not purified in one go. We need to pass the sulfur dioxide from different tanks, right? So that means we have to do its purification. So these all tanks starting from B to this is purification tank. These all are purification tank, in which we are separating the dust, we are separating the moisture, we are making SO2 free from the arsenic oxide. So the first tank, this one, the B1, is called as dusting tower. What is it called? It is called as dusting tower. So here what happens actually, when the SO2 from A tank is fed into the B tank, then the stream of steam is passed through it. Right. So that means this powerful steam is passed. So what happens, that steam just make the dust particles settle at the bottom, and this SO2 just get free from the many dust particles. Not all the dust particles are separated, but many, or you can say many, gets separated. Then after this SO2 is fed from the B tank to the C tank, right? C tank is also called as the washing tower, or it is called as the scrubbing tower. Either term can be used. So it can be called as a washing tower, or it can be called as a scrubbing tower. So when this SO2 passes from this B to C tower, here what happens, the stream of water is passed through it. Right. That means the water is just flowing, there is a heavy stream of water. That then what is it, what purpose it is doing for us? This water actually wets the dust particles which are present with the SO2. Like in the B tower, many dust particles have been removed, but it is not free from all the dust particles. Still it contains a few dust particles. So when it passes from this B to C, then what happens, the high stream of the water makes the dust particles which are left still left with the SO2, it just make those dust particles wet. Then what happened when they just become wet? They settle down, right? And that means SO2 is now free from all dust particles. It do not contain any dust. Then from C tower, it is just fed into this tank, right? This is called as the drying tower, right? So C tank is called as the drying, the D1 is called as the drying tower. So what is what is occurring in the D tower? So the SO2 which is traveling from the C to D is free from the impurities, right? But still it contains you can say a moisture, right? So that needs to be separated out, right? So that means it absorbs all the moisture, and you know that in the C tower as well the arsenic oxide gets separated. But in case like in this figure there are only these tanks, but in many books you will get to see there will be one more tank here, right? So that is the arsenic purifier tank. The tank is similar to the tank we are using in this H2SO4. So what is occurring in that, like when we pass from C to D, all the moisture gets separated. Right now it is free from moisture, it is free from the dust particles, but it contains the arsenic oxide, right? So we just pass from the drying tower to the arsenic purifier, where the arsenic oxide just gets separated, and these all these tanks, that is the one is this dusting tower, washing tower, this drying tower and arsenic purifier, they are just purifying the SO2, and they are just involved in the purification. They are called as the purification units. Now we have just got this SO2 and it is free from all the impurities, right? So till deep tank, our SO2 is now became the pure one. Now what we are doing, we are feeding this SO2 in this tower, the E tower. It is called as the contact tower, right? So that means this SO2 is not now going to react with oxygen in presence of vanadium pentoxide, and it will yield SO3. So this reaction, the second reaction, is taking place in the E tank, right? So at the end, what we are going to have in the E tower, we are going to have sulfur trioxide. Then we are passing this sulfur trioxide into the another chamber that is called as absorbing tower. The F1 is called as the absorbing tower. So what happens in the absorbing tower actually? Here the stream of sulfuric acid is again passed, and with sulfuric acid, the concentrated one. So what that concentrated sulfuric acid is doing, it is just reacting with SO3 to form the highly concentrated sulfuric acid, that is the oleum, right? As I told you, we cannot add SO2 directly into the water because the reaction is highly exothermic, which leads to the explosion, right? So we need our reaction to occur in a controlled manner. So what we do, we pass this SO2 into the absorbing tower, where it reacts with the concentrated sulfuric acid in order to form the highly concentrated sulfuric acid, that is the oleum H2S2O7. Then after this we are passing this H2S2O7 into the G tank. Right, what is this G tank? It is the dilution tower. Here we are mixing the equal amount of water with the oleum, and what we get as a result, we get it is filled with our desired dilute sulfuric acid. So I think it is clear. So you should actually familiar with the reactions first, and then you should familiar with the tanks which are involved. Again I am repeating, the A tank is called as pyrite burner, the B1 is the dusting tower, the C1 is the scrubbing or the washing tower, the D1 is the drying tower, this is the contact tower, absorbing tower, and this is the dilution tank. And here is the beaker is shown in which we are getting a desired product, that is the dilute sulfuric acid, right? So this is the contact process by which we can prepare the king of chemicals, that is our sulfuric acid.